So if you have an integral and there's a radical within that integral where you have a constant, and u a function of x or whatever,
root 4x squared plus 1.
Back to our formulas. As I've said in a previous video, if there's a plus sign and we're using some kind of rule, it's tangent. It's just always gonna be tangent. Plus sign, tangent. You could also remember that the t is almost a plus sign, right?
Am I right?
So let's rewrite this. This is equal to the integral of dx over the square root of 2x squared plus 1 squared. So our u value is going to be 2x and our a value is going to be 1. So now let's do our trig substitution. So we're going to let 2x equal, a is just 1, so 2x is going to equal tan theta, which means that x equals tan theta over 2, and I'm only doing this just to find dx, and dx is going to equal 1/2 secant squared theta.
How did you find that?
So 1/2 is a constant, so we're just taking the derivative of tan theta, which is secant squared theta.
Oh, true.
And multiplying 1/2. So we have our dx. Now let's look back at our original problem and plug in what we know. So dx is 1/2 secant squared theta over, so let's look here. So 2x equals tan theta. So we're gonna plug in our tan theta right here. So we'll have tan theta squared plus 1. Let's go to the side again and let's simplify our radical. Now, if you remember your trig rules, which, Josh, what did I say before? You have to remember your fucking trig rules, okay? Your trig identities, I think these are called. Doesn't matter, you have to know that tan squared theta plus 1 equals secant squared theta. So one more step, simplify this again. The square root of secant squared theta is just secant theta. All right, so let's rewrite our integral with our new information and this simplified radical. We have 1/2 secant squared theta over secant theta. Look how nicely this works out. This is gonna cancel with one of these, and we can rewrite it again. I'm gonna pull this 1/2 out. So we'll have 1/2 times the integral of secant theta. The integral of secant is ln secant theta plus tan theta. And don't forget, this is all multiplied by 1/2. So let's look at our original problem. We have this in terms of theta, we need to get this in terms of x. So up here we had that tan theta equals 2x. So that's tan theta equals 2x over 1. Those are the same thing, right? So if we look at our triangle here, let's look back at our SOHCAHTOA. Tangent is opposite over adjacent. So our opposite of this angle here is 2x, and our adjacent is 1. Now we have to do our Pythagorean theorem. We have a squared plus b squared equals c squared. Well, our a squared is just going to be 1. Our b squared is going to be our 4x squared. And we're solving for c squared. Excuse me, we're solving for c. So we take the square root of both sides, and holy shit, it's the same fucking radical from the beginning. Now we can solve for the rest of this triangle here. Now we have radical 4x squared plus 1. We evaluate these individually. Let's do secant first. So secant is equal to hypotenuse over adjacent, because remember, it's 1 over cosine. So our hypotenuse here is root 4x squared plus 1, and our adjacent angle is just 1. Let's look at tangent. Tangent is opposite over adjacent. So opposite, 2x, adjacent, 1. We just have 2x. So we're gonna have 1/2 times the natural log of root 4x squared plus 1 plus 2x. Oh my God, and plus c. Didn't forget this time. Proud of me? Say you're proud of me.
Nah, dude.
Josh, you ready for this one?
Mm-hmm.
All right, Josh, look at this problem, and you tell me which one we're using.
Well, I see a minus sign. I see a minus sign right here, but oh, and the x is on this side, so that's the u squared, right?
Bro, you a young Terrence Tao, dude. Yes, this one's a secant example. We have our u value out in front this time. So let's rewrite this once again as the integral of x cubed over x squared minus 5 squared. Man, Josh, you be killing it, dog.
Wait, how about?
What'd I do? Oh yeah, root. Sorry, yes.
Come on, bro.
Our u value is going to equal x, and our a value is going to equal 5 here. So since our u value is out front, we're going to let x equal 5 secant theta. That means our dx is going to equal 5 secant theta tan theta. So now let's plug back all of our information into our integral. So we're going to have 5 secant theta cubed times, don't forget dx, times 5 secant theta tan theta all over the square root of 5 secant theta squared minus 25. Let's do a little side work here and simplify this radical.
I got the burner in the back seat if she out of line. Burner in the back seat if we out of town. Burner in the back, yeah, you know I stay strapped. Burner in the back.
Okay, so we plug everything back into our integral. We have the same thing on top, but now on the bottom we have 5 tan theta. All right, so it works out nicely. We can cancel one of these 5s, and we can cancel this tangent here. And what we're left with is 5 secant theta cubed times secant. So let's cube this 5 and cube this, and this will equal the integral of 125 secant theta cubed times secant theta. Let's pull out this 125, and we have the integral, if we multiply these two, of secant 4 theta. This one's a little trickier. We're gonna have to use some trigonometric integral techniques. Let's split this up into secant squared times secant squared, because we know secant squared equals 1 plus tan squared, and I think that's gonna help us solve this integral. All right, so we split it up. Now let's rewrite one of these as 1 plus tan squared theta. And now we are going to distribute the secant squared theta. So now that we have this plus sign, we can evaluate these as two separate integrals. So we really have 125, don't forget that this applies to both integrals now, this 125 here. So we have 125 secant squared theta plus 125 integral of secant squared theta tan squared theta. Now this works out nicely because we know that the integral of secant squared theta is tangent theta. So we have solved this one already, 125 tan theta. Now on this side, we're gonna just use a simple u substitution. We're almost done. If we let u equal tan theta and du equal secant squared theta, we can rewrite this integral as 125 times the integral of u squared du. And we know the integral of u squared is just going to be u cubed over 3 times 125. We plug our u value back in, and we have 125 tan theta cubed over 3. Let's bring down this information, and we're left with 125 tan theta plus 125 tan theta cubed over 3. So we have our answer in terms of theta. Now we need to draw our triangle to help us rewrite this in terms of x. So back to the original problem, we remember that we let x equal 5 secant theta. But if we divide each side by 5, we get that secant theta equals x over 5. Let's look at our SOHCAHTOA. Secant is equal to 1 over cosine. So x is our hypotenuse, 5 is our adjacent. So x here, adjacent here. So now we need to solve for the opposite side. I'll bet $100 million that it turns out to be that radical. But let's just, for the sake of math, let's just do it. 25.
No way.
Dude, crazy. Crazy. So we can fill in our triangle, x squared minus 25. Now, we can plug in values here. This is gonna be equal to 125, tangent, opposite over adjacent. We have opposite and adjacent. 125 root x squared minus 25 over 5. Plus, let's write our constants first. 125 over 3, and we already know what tan theta is equal to. Root x squared minus 25 over 5, but except here, remember it's cubed. Look, I mean, I spent a minute trying to factor this after we got this answer. I went this far and stopped. You could get rid of this 1/3 if you want. It's not a big deal. This is correct. I didn't forget plus C this time, so you should be really proud of me. And yeah, we've done a bunch. We did a bunch of tricks up today.
I feel like Tyler would be so good at this.
Yeah, that game, yeah.
I go.
I did that
Ready?
improv.
Yeah.
Thanks for watching. Click like and subscribe right now if you love
Doing
doing
cow. All right.